My name is Najihan Nika Suraya binti Muhammad Ali Pempati with matric number 111210.
Hi, my name is Hanifah Shrina binti Ilham. My matrix number is 110106 and I'm from group 6.
Hi everyone, my name is Mashita binti Muhammad Zaki and my matrix number is 110734.
Hi, my name is Kasma Cerida with matric number 110451. I'm from team 6.
Hi everyone! For practical 2A, spectrometry, let's learn about sugar analysis using the 3,5-dinitrosalicylic acid DNS method. 3,5-dinitrosalicylic acid DNS is a key reactant in biochemistry for quantifying and reducing sugar, lactose from ligonosalicylic biomass hydrolysis like pentose, hexose, and oligosaccharide. The method targets free carbonyl group, C-carbon O, in sugar such as glucose and fructose, oxidizing them while simultaneously reducing DNS to 3-amino 5-nitrosalicylic acid, originally for single sugar. It's now widely used for mixtures.
Objective: to determine the absorbance of the solution using spectrophotometers with different concentration, to observe the changes of color at different concentrations, and to determine the linear equation of the graph.
We have a few materials that we use for this experiment. The first one is spectrophotometer. The second one, hot plate glass beaker. The third one, cuvette, and continue with test tube and test tube rack, micropipettes and tips, distilled water, standard glucose solution 10 gram per liter, sodium potassium tartrate or known as Rochelle salt, and dinosalicylic acid reagent.
Methodology. First, the following reagents were duplicated in pipette and turned into a series of dry, clean and labeled test tube as indicated in the following table. After the above-mentioned solution in the labeled tubes were replaced, the test tube was shaken and then placed them in boiling water bath for 5 to 7 minutes. The tubes were cooled, added 1 ml of Rochelle salt, then transferred the solution into cuvette. The extinction of the colored solution at 575 nanometer using test tube 1 as a blank was read. The reading and the plot relationship between the optical density and the concentration of glucose solution was recorded to see whether there is a linear relationship between the concentrations of glucose solution and their corresponding optical densities.
Results: the data clearly shows an overall increase in average absorbance as the glucose concentration increases, which is consistent with the Beer-Lambert law. 2 absorbance readings were taken for each concentration to ensure reliability. The standard deviation is generally low, except notably high at 0.6 gram per liter and 0.8 gram per liter. This indicates a significant variation between the 2 replicate readings at these higher concentrations, suggesting potential pipetting errors, temperature variations, or inconsistent mixing during the assay preparation for those specific tubes. For the graph, the initial data points show a strong, nearly perfect linear correlation between concentration and absorbance. This region adheres well to Beer's law. The equation y equals to 1.4134x minus 0.0285 was used, where y is the absorbance and x is the glucose concentration. This equation provides the calibration necessary to determine the concentration of unknown samples. At higher concentrations, the data points fall below the calculated linear regression line and begin to plateau. This deviation or flattening of the curve suggests the reaction is entering a saturation phase. At these high substrate concentrations, the DNS reagent itself may be the limiting factor, meaning all the available DNS reagent has been consumed and reduced, regardless of how much more glucose is added. For accurate measurement of unknown samples, only the linear range should be used, as the concentration and absorbance are reliably proportional in this zone.
As for discussion, number 1, experimental results. The experiment successfully generated a usable glucose calibration curve. Linearity, the plot showed a linear increase in absorbance at 475 nanometer as glucose concentration increased. Compliance, this linear relationship indicates adherence to Beer-Lambert's law. Consistency, duplicate tubes showed only small differences, suggesting that pipetting was linearly consistent across the experiment. Number 2, reaction mechanism. The DNS method is colorimetric assay used to quantify reducing sugars that possess free carbonyl groups. Chemical change, under alkyl conditions, reducing sugars reduce the yellow DNS region into 3-amino 5-nitrosalicylic acid. Color change, the reaction causes a visible shift from yellow to orange-red. quantification, the intensity of the orange-red color is directly proportional to the sugar concentration. Number 2. Procedure and regions. Key steps in the practical experiment include 1. Mixing the sample with the DNS region. 2. Heating the mixture at 80 to 100 Celsius for 5 to 15 minutes. 3. Cooling the mixture and measuring absorbance spectrophotometrically. 4. Ratio salt. This is added after cooling to stabilize copper ions in the alkaline solutions, preventing a precipitation and ensuring accurate detection. Number 4. Sources of error. While the results support the validity of the method, slight deviations from the straight line may have been caused by procedural variations, differences in mixing, wrong timing or incomplete cooling, measurement issues, inaccurate volume measurements, or temperature fluctuation in the water bath, optical interference, bubbles or fingerprints on the cuvette affecting light transmission. Conclusion: this practical successfully produced a glucose standard curve using the DNS method, demonstrating a clear positive relationship between glucose concentration and absorbance at 575 nm and fulfilling the objective of preparing a calibration curve for quantitative sugar analysis. The color of the solution becomes darker from test tube 1 until test tube 5 as the concentration of glucose increases. The average number of absorbances is increased due to the increase in concentration of glucose solution. A linear equation for the graph of concentration in GL against absorbance at 575 nm is y equals to 1.4134x minus 0.028. The generally linear trend and reasonable agreement between duplicates indicate that the method was reliable within the tested concentration range, making the curve suitable for estimating unknown glucose concentrations in subsequent experiments, as long as similar experimental conditions are maintained.